questions on calculator stuff? Okay. That's everything on the left side, right? What are you getting? Oh, second, and then there's a button on the bottom. It's like a blue L. That's everything on the left side, right? As I'm for once moving straight through. Okay, so on the right side, a person rolls doubles. We're rolling 2 dice here. If he rolls doubles, he wins $5. So this kind of goes back to what we dealt with days ago when we did the dice rolling thing. How many ways can I roll a double? So if my first die is a 1, how many values could my second die be to be a double? So if my first die is a 2, how many values of my second one could be? So how many total options are there going to be? 6, because there's double 1s, double 2s, double 3s. So there's 6 total outcomes that have doubles out of how many total outcomes on a die when I roll 2 dice. So there ends up being a 1 in 6 chance that you roll doubles. Everybody with me there? Because that's from the other day. So here we're just saying we're going to call this x for x and give x for right now. But we're going to do this as, I'm going to kind of call this one either win or I lose. If I win, what do I win? What is my probability of winning? If I lose, what do I lose? If I lose, how much do I win? What is my probability of losing? How do I know that? Because it's the complement of this. So now I can do this for the possible winnings. Now, if I'm just doing 2 things multiplied together and one of them 0, I'm probably not going to waste my time to go through the table in the calculator. So mu of x, what would I write? I'm multiplying. So it's my first x value. 5. I'm multiplying 5 times 1/6. I'm doing what in between? Adding it to, well, what's 0 times anything? So what's my answer going to be? Now, if we're talking about it like money, because it would make more sense here, what's 5/6 as a decimal? So what this is saying is people playing this game, on average, every time someone plays this game, they are winning about 83 cents per game. So now we're kind of starting to bring in the game, casino, gambling aspect into things. All right, but what is this problem not talk about at all that is extremely, extremely important? How much you actually lose, or how much it costs to play it. So part B, we're going to think about that. So what if I cost $2 to play? So now let's think about it in a different way. So let's look at it as net gain. So I usually do a whole bunch of labels for mine. Your chart is going to be your net gain and your P of X. But I do 2 labels above. I do what my winnings were, and sometimes I do like a category label. Now this one is going to be easy, but so here I'd be like, I win or I lose. If I won, how much, what were my winnings? Just in general, how much? 5 and 0, so that's from our last game. So now when I look at it as net gain, I'm considering how much I paid. So if I paid $5, or if I paid $2 to play and I won $5, my net gain is. So for those of you who like definition things, how do I find net gains? You're winning what?
Minus your loss.
Minus your losses, or how much it costs to play. Alright, so what was my probability that I win? What's my probability that I lose? So now I'm doing 3 times 1/6 plus a negative, or minus 2 times 5/6. So I have negative 10/6 plus 3/6, which is a fraction is what? Which as money is. Yeah. What do you notice about that? Does that number stand out or make sense at all? So you are, on average, people playing this game lose an average of $1.17 per time they play. Does that seem bad? Does that seem realistic? I always talk about things in terms of a casino. A casino, by definition, is a what? Their whole sole purpose is that they are a what?
Scam.
They're a business. Not a scam, but they're business. Well, what's the whole point of a business? Make money. So they better be making money on average, or they're not a casino business anymore. So literally every casino game you play has a negative value that people on average lose a certain amount of money every time they play. Like, that's the whole point. But why does the number 117 make sense? The other one was 83. So I took 83 and did what with it? Subtracted
the amount that you paid each time.
Amount that you paid each time. So if I did the mean the first time and calculated it and then subtracted by 2 from that, did I really need to start over? No, I could have just gone. So like, you're getting there the same way whether you do the minus 2 to each piece individually here, or you wait and do it at the end. 0.83 minus 2 would give us that.
Just like -2 plus the mean.
So, starting at B down the entire rest of the worksheet is expected value. But expected value is just the what? What is this? Mean. Sometimes they write expected value as E of X. It's just the mean, but it includes like your wins and your losses, your net gain stuff. So net gain, or mean and expected value, you're doing the exact same thing. Yeah. Alright, so let's look at this one. If a player rolls 2 dice and gets a sum of 2 or 12, they win $20. If they get a sum of 7, they win $5. The cost to roll the dice once is $3. So we're basically starting straight at B because we get what's going on here. So we've got our winnings, our net gains, and our P of X. And then I usually do like a category label above. So what are my, it talks about sum of 2 or 12. It also talks about a sum of 7. How much do I win if it lands on a 2 or a 12? $20. How much do I win if it lands on a 7? So I can calculate my net gain. So how much did it cost to play? $3. So if I won 20, but I paid 3 to play, my net gain was if I won 5, but I paid 3 to play, my net gain was actually. So see if y'all can remember back to the other day when we did this stuff. What's the probability of rolling a sum of 2? 1 out of 36 was probably rolling a sum of 12. So what should go here? And I don't ever reduce here because of what I'm checking. And it makes it easy on me. So do you remember what the probability of rolling a 7 was? A sum of 7. What issue do we now have? That does not add up to 1. So is this right now a valid probability distribution? No. So that means something was here. So I can just write this category as other or lose. So in these categories, how much did I win? 0. Which means my net gain was. So 6 here, 2 here, total of 8. So how much is left? And then so find this is my symbol for expected value. Which is, I'm just writing that instead of mean. I'm dealing with the net gain stuff. So now 17 times 2 out of 36 plus 2 times 6 out of 36 minus 3 times 28 out of 36. And usually if it's if it's something like this, I'm probably not going to take my time to do a table for 3 like this. I think it would be more time consuming to make the table, but that's totally up to you. So a lot of this you can do in what's 28 times 3? That's the only math you have to do really. What's 28 times 3? 84. Well, this together is 8. This together is 34. You just said this is what? 84? Oh, no, right. 8. No, do the other one for you. Okay. So these together give me 46. So I have a positive 46 and a negative 84, which gives me what? Is that right? So 72. Yeah. And then it makes more sense to do it. Now you can type it in and skip that, but people who are just good at doing math off the top of their head, it's just as easy. Numbers wise, like money wise, that would be negative 1 point what? So on average, people playing this game would lose about $1.06 per game. Which on the opposite side means in the long run, like in a day's work, what does that mean for the business about people playing this game? By the end of the day, on average, they made $1.06 every single time anybody plays this game. So like in anything that ever exists, this is the background to it. Anytime you go buy an electronic device and other things, they always say when you go buy it and you go check out, what's the first thing they ask you about it? If you want what? If you want what with your new device? What? When you're checking out, would you like to purchase what? A warranty. Or insurance, whatever you want to call it. And they give you some random number like it's going to be $15 or $18 or something. Do you think somebody just sat in the room and be like, I think let's make it 24. That sounds good. Like, do you think they just like picked a number out of nowhere? They did this backwards to decide what the cost should be. So like if they came up and found the probability of different issues that happen, and now obviously it's a whole lot more advanced than us just drawing this problem up here. It probably took years of research, but they did this whole process to figure out what are the chances of this happening, how much is the cost to fix that, and then use that to determine what your actual insurance is. And this is the whole idea behind that warranty cost or your insurance. But this is the first time you've ever seen that. It's probably the first time I've ever thought about where they came up with that number too. I want y'all to do this one. Yeah.
For this scenario, would the same number be again?
Less. You're entering a contest where you pick 2-digit number, 1-digit number be selected. Oh, I should have said no. So, like how it says then another 2-digit, it should say you're right. It should say something about no. The first two cannot be picked again. Sometimes these problems do a little bit worse about making it implied instead of explicit.
Two-digit number includes 0009.
Yeah. No, wait. 002.
I mean, does it,
Yeah. Yes. 00 is included. And I told you I do a lot of things like where I write net gain and I write winnings and I write a label category. Y'all are going to do kind of a mix of those. It's going to be a preference thing. But the thought process is still there for all the things that I write down, whether you write them all down or not. And sometimes the more complicated a problem gets, the more like labels I choose to do. You're not thinking about that way. And here, I usually do a label and a winnings, but your winnings kind of is your label, so that kind of seems. So how many possible outcomes are there? How many outcomes up here are there? 4, because you have to consider the fact that you could lose. How many people are going to win $100 or win $50? How many people are going to win 25? How many people are going to win 10? How many people are going to lose? If I do this math and I get negative 2.2, my answer is obviously wrong, but why should I immediately notice that? If it only costs $2 to play, how in the world can I lose 2.2 on average? So like looking at being able to think in context that way catches a lot of issues.
Is this like not replacement?
Okay, so the way I asked it is the way you think about it. So it's like they've done everything, so everybody had an equal chance. So what was the chance? Like how many of them won $50 won out of how many 100? So like it's almost going straight from chapter 5. It's almost easier to think about it that way. So like anytime we're doing expected value for this class, we're not doing anything with replacement or without replacement. And what do we end up getting as our answer? Say it again.
Negative $1.15.
Just to be able to talk about this, what does this one go to 4 decimals? Or is it exactly?
It's exactly.
Okay. Could I write something that's negative $1.1542? Is that still correct for the average amount that's lost? Just because we deal with money that stops here, would it still be an interpretation to talk about something as an average? So like the average family has 2.32 children. Is that a correct thing to say? Yes, because it's on average in the long run if you split them up equally. Does that mean somebody has 0.32 of a children? No. So even if it's something that can have more decimals than the way we talked about it in context, that's fine. I want to do one of two. The insurance policy one. That's a quick one. Do the insurance policy one. This one actually makes sense because it's kind of like the insurance for a electronic device thing concept. And it's surprising really quick. I want to make sure I can talk about this. We're going to talk it as you write it. How many options are there? 2. What are they? Either is destroyed by fire or it's not. Now, the one important thing about this problem is it changes your perspective here. So, if there is a fire, so this is the amount of money that the company makes. If your house does not have a fire, how much does the company make net gain? $300. If you paid $300 for insurance and they have to pay you $200,000, what was that company's net gain? Negative $1,999,700. What's the probability that there is a fire? Which makes this one. Is $300 very much to pay for home insurance if they're going to replace your house? Relatively no. At first glance, looking at this problem, most people would think a $300 house payment to get $200,000, there's no way insurance could stay in business because that's no way they can make up for that, right? What do you end up getting? What? Even with insurance companies having to pay out $200,000, they would still be making an average of $260 for every payment made. So should you be feeling terribly sorry for them? No, they're still making a lot of money off that. But I think that's one of those that kind of perspective gives you an idea.
Money from the money they use.
And they, even though it's a small amount, they add up so quickly, so unlikely, and people are like, woo.